Hey everyone, and welcome. Today, we're going to dive into a really powerful way of looking at data, graphs. And no, I'm not talking about the bar graphs or pie charts from your last presentation. We're talking about a data structure that's all about finding the deep, often hidden meaning in how things are connected to each other.
So you're probably super familiar with databases built on tables, right? Rows and columns, all neatly organized. They run so much of the digital world. But here's the thing. What if the real story, the most valuable insight, isn't actually in those neat little rows of data, but in the messy, tangled web of connections between them?
And that right there is what we can call the relationship problem. It's this moment when you realize the connections matter more than the things themselves. And to really get a feel for what I mean, let's jump into a classic scenario where our trusty tables start to feel, well, a little clunky. Okay, so picture Charles on some social network. He writes a post and sets the privacy to friends of friends. Now, just take a second and think. How would you figure this out using standard database tables? You'd have to, grab a list of all of Charles's friends? Okay. Then for every single one of those friends, you'd have to run another query to get all of their friends. You can see how this gets complicated and really slow, really fast. And that is the absolute heart of the issue. Sure, you can do this in SQL with a bunch of complicated joins, but the database, the whole structure, it wasn't really built for that kind of work. Every degree of separation you add just makes the query slower and more complex. You're basically asking a table to do something it was never designed for, to follow a trail of breadcrumbs. So if tables aren't the right tool for this job, then what is? Well, the answer means we need to completely rethink the shape of our data. So let's talk about the graph data structure. Put simply, a graph is a data model where the relationships, the connections, are treated as first-class citizens. They're just as important as the data points themselves. The entire system is built from the ground up to handle connected data. Now, graphs really only have two basic building blocks. First up, you have the vertex. The easiest way to think about this is as a node, or just a dot. This dot represents a single thing, an entity. It could be a person, a product, maybe a web page. And the second building block? That's the edge. This is the line that connects two of those dots, two vertices. But here's the crucial part. An edge isn't just a line. It is the relationship. It has a name and meaning, like is friends with, or links to, or purchased. The edge is what gives the connection its context. Okay, so let's rewind and tackle our social network problem again, but this time with our new graph mindset. Each person, Anne, Bill, Charles, they're all a vertex. Easy enough? The friendship between them, that's an edge called is friends with. So now, how do we find Charles's friends of friends? No more messy queries. You literally just start at the Charles vertex and you walk along the edges. One step out to his friends, and then a second step out to their friends. It's that simple. It's just so much more intuitive. Now, this all sounds like a really neat, elegant concept, right? But is it just some academic idea? No way. The truth is, you are using massive, world-spanning graphs every single day, and you probably don't even realize it. Let me show you where they're hiding. I mean, the most obvious one is social media. What do you think platforms like Facebook or LinkedIn actually are? They're just one gigantic graph. Your profile is a vertex, every friend connection is an edge. That whole people you may know feature, that's just the system looking at the graph and saying, hey, you're only 2 hops away from this person through a bunch of mutual friends. You should probably connect. And it's not just people. The entire World Wide Web? Yup, it's a graph. Every single web page is a vertex, and every hyperlink is an edge pointing from one page to another. This is exactly the idea that Google's original PageRank algorithm was built on. They realized that a page with a ton of important pages linking to it was probably an important page itself. They were just analyzing the structure of the web graph. Or what about when your favorite streaming service recommends a movie? How does it know you'll like it? You guessed it. It's a graph. You are a vertex, and every movie is another vertex. The rating you give creates an edge between you and that movie. The system then looks for other people with similar tastes, similar patterns of edges, and recommends movies they liked that you haven't seen. So we've seen how powerful graphs are, and that they're everywhere. But this brings us back to a really important question. If you can technically represent all this stuff in tables, why do you even need a graph at all? Let's break down the fundamental difference. Now look, to be fair, you absolutely can store graph-like data in a regular relational database. You'd have a table for your vertices, your people, with their IDs, and then you'd have a second edges table that just uses foreign keys to connect those IDs together. So looking at this, it's totally logical to ask.
Exactly this. It's a perfectly fair question. If the data can technically fit into a structure we already know and use all the time, why on earth would we bother with a whole new system like a graph database? And the answer, the whole reason this matters, comes down to one single word: optimization. It's not about what you can store, it's about what you can efficiently ask. Relational databases are optimized for aggregating data within tables. Think finding the average price of a product. Graph databases are optimized for traversing the connections between entities, finding paths, discovering communities. For those kinds of questions, the performance difference isn't small, it's monumental. And that really brings us to the key takeaway. If you remember just one thing from this whole explainer, please let it be this.
This quote just nails it perfectly. We are focusing as much on the connections between entities as on the entities themselves. That's it. That's the whole game. You choose to use a graph when the connections are the main event, not just some secondary detail. This requires a real mental shift. In a graph, the relationships aren't just little pointers from one thing to another. The relationships are the data. An is friends with connection or a purchased event is a piece of information that's just as valuable as the people or products it connects. So, I want to leave you with a question. Think about the data you work with every day. What hidden connections, what invisible stories are lying dormant just beneath the surface? What complex questions about relationships could you finally answer if you stopped looking at your data as a table and started seeing it as a graph? If this helped you see data in a new light, please do us a huge favor and hit that like button, share it with a friend, and subscribe for more explainers just like this one. Thanks for watching.